Welcome to today's FDTD Go 16 Applications webinar, and today we're pleased to have Stan Zizek from the WFO in Las Vegas leading the presentation for today, and he'll be discussing utilizing Go 16 data in the desert Southwest. First, we'll go over some protocol with these first couple slides. First of all these are recorded and available on the visit pages at the URL that we show here. Also, if you're interested in leading one of these in the future, just let us know. I'm Dan Bicus or Scott Lindstrom. Just let us know if you're interested in leading one of these. A few things to go over. Our speaker will have about 20 minutes for presenting his topic here. And if you have any questions, you can send them either the go-to chat or at the end of the talk. He'll have up to 10-minute period of Q&A over the phone. And we'll be done by 18:30 UTC. Remember, do not press hold, and remember to mute when you're not speaking. So at this point, I will turn it over to Stan.
All right, thanks a lot, Dan. So in this presentation, we'll take a look at how we've been using Go16 data in the desert Southwest. In some ways, it will probably be quite typical to what a lot of other offices are, but there may also be a few unique things that I've got to show, and some of the weather that we have to deal with out here. So I'll be covering several dust events, fires, enhanced convection, our problems with data void areas, and also a tool that we have to help with making mesoscale sector requests. We'll start off here with dust events. This first image is from back in March 14th of last year. And really, this is GOES-15 visible imagery. And the area of interest is near Scotty's Junction, relatively close to the center of the page. And then really what I'm showing here is you're not able to see a whole lot going on in this particular image. It's a little jumpy as well, but really this is what we had available only by looking at GOES-15. In this next slide, I've got GOES-16 data. And on the left is channel 1, and on the right is channel 5. And hopefully you could see quite a bit better in the area that I've got highlighted right around Scotty's Junction and the center of the screen there. In both of those channels, you should be able to see a small area of blowing dust that got picked up from the dry lake bed, and that plume was then moving across Highway 95 there. And in this particular case, just ended up causing some minor problems. But definitely noticeable difference between 15 and 16 satellites. So here's a look a couple of weeks later, on March 30th. What we're looking here is got an area highlighted just near Sandy Valley. In the oval. You can see some high cirrus coming across, but there's a dry lake bed south of Sandy Valley, and you could see a little bit of dust being picked up and a plume generating at the beginning of this event. This area many times is a typical source region for dust that ends up making its way into the Las Vegas Valley. And at this particular time in this event, this was the beginning of a larger event. With GOES-15 data, I don't have it here, but it was a lot harder to make out the blowing dust underneath the cirrus. Much easier, again, with channel 2 here on GOES-16. So a couple of hours later, into the northwest, got another area of blowing dust just south of Shoshone, heading off to the northeast towards Pahrump. Again, this was clearly evident on channel 2 during this day, and again, as we go through this event, you'll see several of these plumes get quite significant. This particular we were able to utilize this information and share it on social media to help get the word out for potential issues near the town of Pahrump and along Highway 95 that might be posing some travel difficulties along Highway 95 because of the blowing dust. So again, a couple hours after that, point out two different areas. One with a northern arrow pointing out a big wall of dust coming through. That's Inyo County, and it's starting to move into the northern portions of Death Valley National Park. And then down with a second arrow, just to the east of Furnace Creek, you could see a second area where there's another wall of dust making its way into the southeastern part of Inyo County and that portion of Death Valley National Park. A few minutes later, that wall makes its way into Death Valley Park and moving towards Death Valley Junction. That's going to have some major impacts into that area over the next hour or two. You could see elsewhere in that image, just up to the north, there's several other plumes and walls of dust continuing to work their way from north to south, as well as a series of dust plumes working west to south ahead of the cold front, from west to east ahead of the cold front across San Bernardino County here. So here's a look at RGB image, a longer loop throughout a larger portion of the evolution of the system. And you can see as the front pushes through and enhanced convection helps to kick up even more dust. Because the RGB really helps to highlight where the areas of dust are, especially the more notable areas. And you can see in the inset image that was tweeted out what that looked like on the ground as that wall of dust worked its way into Furnace Creek near the visitor center. So some major impacts as this progressed through. And also towards the end of the loop, you could see as it makes its way into the Las Vegas Valley, the RGB does a good job of highlighting the dust out ahead of that as well. So here's in the upper left, we're looking at channel 2, and you can see several north to south plumes up across the north, and again that wall of dust coming down. And then further south across San Bernardino County, ahead of the cold front, many of the plumes are still blowing from west to east. Over the next hour or two, a lot of those will kind of merge together, and you can see in the image in the lower right, the most substantial wall of dust that formed across southern San Bernardino County and then worked its way into Phoenix's forecast area. So many of the tools, many of the channels from GO16 were quite valuable during this event and, of course, several others. So another thing that we have been utilizing, one of the forecasters here did some work with the USDA Natural Resource Conservation Service. They've got this soil system where they have 8 different levels of wind erodibility. So again, it's this wind erodibility groups. On this image, I'm highlighting just 3 of the levels, the top 3 levels that are most susceptible. So in level 1, kind of highlighting an area in the color that we have this information available within AWebs. Again, they're the very fine sands and most susceptible. Level 2 are loamy, very fine sand, and level 3, very fine sand and a sandy loam. So we've got quite a few areas across San Bernardino County, but elsewhere scattered across our forecast area, you see a lot of these dust-prone areas. So we try to utilize those to help us in our anticipation of blowing dust problems. So in this image, during an event in June, we're looking at channel 2 here, and I've got the WEGs contoured, and I've got a couple areas of 1 and 2 highlighted. And you can see with the fairly strong southerly flow, wind speeds averaging 25 to 35 miles with gusts of 40 to 50, some higher localized gusts upwards of 70 to 75 miles per hour. You can see off of each of these, many of these WEG 1s and 2, quite a bit of blowing dust picking up. That's correlated quite well with those areas. Here's another area. This is just south of Shoshone. You can see a really small area of WEG 1, but that's enough to produce a quite substantial plume of blowing dust once that's activated. This was the same day, and was also still looking at channel 2. So it doesn't take a large area to produce a more widespread dust plume that can affect a large area. So this is the same day, June 11th, looking at channel 2. And you can see several south to southwest plumes in California that are blowing from the south up to the north-northeast. And then towards the end of the loop, kind of see a wall of dust that's forming up near Lida and Scotty's Junction, and ahead of, or right behind a cold front. Another thing to point out is just to the east of Independence, you could see the plumes were all going from south to north. Then as the front comes through, you could see that one plume that kind of reverse direction, and the plume then goes from a north to southerly direction. This is the same event, kind of focused in on that wall of dust that comes into to Lida and Lida Junction there. Then also at the same time looking at, in the lower right, the dust RGB, which again does a good job of highlighting areas of dust, as you can see. So next up is take a look at some wildfires. We didn't have a whole lot in our forecast area, but was able to utilize some tools with some of our neighboring offices. I'm looking here at channel 1, the visible channel, and also channel 7, shortwave IR, and I'm highlighting just the values that are greater than 45C. Those sorts of temperatures work well earlier in the season, but with the intense heat in the southwest, eventually have to kind of ramp up that threshold because the whole area becomes hotter than that. But you can see that there's a number of fires. There's probably about 15 in this image. But most of them, many of them anyway, have the hot spots kind of correlated with them, utilizing channel 7. And there's probably about 6 or 7 in Arizona and 4 or 5 in New Mexico, and some in northern Mexico as well. Here's a look at Brian Head Fire. That was in southwest Utah in June. In the upper left RGB, you can really see how that helps to distinguish the smoke from the cloud. Looking at the RGB and also the channel 13 IR. And then we have the visible channels, channel 1 in the upper right, channel 2 in the lower left, and channel 3 in the lower right. Certainly you could see the smoke plume in all of those channels, but it shows up quite a bit better with the true color RGB in the upper left. It kind of, like I said, helps to delineate the difference between clouds and smoke. We'll take a look at some enhanced convection that we had this past season. One way we were looking at some of the data was with this event in August. In the upper left, looking at channel 1 combined with channel 7 shortwave IR and highlighting areas that are hotter than 60C. In the upper right, I've got channel 2 visible and channel 13 IR, and with that I'm highlighting the IR temperatures that are cooler than minus 60C, so highlighting some of the convective cores. And then in the lower left is the channel 3 visible image, and then in the lower right, several different fire images, fire temp, power area, and fire detection RGB. And you can see it does a pretty good job of highlighting the hot spot over the Sierra that you could see, and particularly in the upper left image with the smoke plume that's being sent off to the east. Kind of highlight several of those areas that I was kind of referencing with the different hot spots and the cooler cloud tops, as well as the fire detection. So on that same day, kind of zoomed in here and kind of combined 3 different channels. One was channel 1 visible, and that combined with channel 7, highlighting the hot spots for the fire detection, and then highlighting the colder cloud tops with the channel 13, highlighting those where the IR temps were less than minus 60. So it was when we had a lot going on that day, it was nice to have all of these kind of combined together and be able to assess various things all at once. Next up, I've got data void areas. That's another problem we have to deal with out across much of the West, especially the desert Southwest. Kind of just wanted to highlight some of those issues for those who aren't quite as familiar. But on the left, I've got the various colors are highlighting the radar coverage at 4, 6, and 10,000 feet. So you can see a lot of central Nevada, eastern California has little to no coverage. And then looking at 16,000 feet, that expands a little bit, but still there's quite a few areas where you're just not seeing any of the low levels with any of the radars that are out here. So let's just see here. During this event, back in, I believe it was August, looking at IR channel 13 and helping to use this channel with our winning decision making. That combined with cloud top heights that are available, it's kind of highlighting that area where the stronger convection is, where there's IR temps around minus 60, cloud top heights are about 45,000 feet. With a half-degree slice off of Reno's radar, that's already at about 18,000 feet. With these stronger storms, we were actually able to get a look at those, but all these tools together helped us paint a better picture and help with decision warning making due to the limited radar coverage that we have to deal with. Mesoscale sectors, we had requested, our neighbors requested a number of those, and that provided a major increase in the temporal resolution, as well as the spatial resolution, providing new details. So both of those have paid huge dividends with us particularly during the monsoon season with convection. Let's see here. Just go ahead and advance to the next slide here. There we go. So another thing to point out was parallax. On here I've got channels 2 visible and channel 13 IR. I've got the areas colder than minus 70 C highlighted. You can see some really strong convection this day. And I've also got lightning data thrown on there. And you can see that the parallax between the lightning and the convective towers it's about 8 miles at about 330 degrees. So on this day, the radar had gone down, so we were relying on these and other tools to help us with our warning decision making, and particularly in that scenario, having an awareness of the parallax is key. And again, having a mesoscale sector paid huge dividends, and we were able to be successful with our warnings on this given day. And try to get to the next slide here. So one other thing we developed was to help with our mesoscale sector requests. A little tool one of the forecasters put together. And instead of trying to come up with what launch should we select for a given day, during the monsoon season we came up with 4 different sectors that should cover most of the situations. We had one standard monsoon, one that covered the eastern area, most of Arizona and New Mexico. If we had a tropical system, we had one further south to highlight that area, and then another western one to highlight California as well as our area. So we kind of had these pre-canned sectors available to the forecasters when they were going to conduct a mesoscale request. And that was added to the situational awareness display that we have. So you just go in there and click on a button, and that calls up the predefined sectors. We also have the MDS monitor and the MDS preview tool available in this little GUI. And that paid some nice dividends during the monsoon. It also helped us play nice with our neighbors. So, in advance of a particular event, we're trying to consider what would be best for us and our neighbors, depending on where the convection was expected on a given day. Basically, I think I covered most of the items on this particular slide, but that's kind of what the usefulness of the tool, what some of the dividends were for us. So some takeaways. GO16 is the increased temporal and spatial resolution have paid huge dividends, particularly with respect to areas of blowing dust and radar data void areas. The increases in resolution provided increased lead time for a number of events that we had to deal with. And the GO16 data, in conjunction with those wind erodibility groups, have provided improved situational awareness as well. Parallax is something to be keenly aware of, particularly when the satellite data is being used in warning decision making. And having predefined sectors for mesoscale sector requests has saved time and improves collaboration. And I think that's my last slide. So, any questions?
Stan, I do see you have a question from TJ Turnage submitted over the GoTo. He asked, would Channel 1 pick up dust better?
On occasion, but it seems with the better spatial resolution with Channel 2 that more often Channel 2 does a better job.
Yeah, I think that's the key. The resolution's better, and if you did have some ambiguity with clouds mixed in, that an RGB product I think would help even more.
Yes. Yep.
Any other questions for Stan? Well, I guess I'll throw in a question or a comment anyway. I know you talked a little bit about Parallax, and that was when it was in its central position, the GO16 central position. It's now a little worse for you with the east position, but once GOES S comes along, it should be quite a bit better for your region, or I should say not as bad for your region. So just keep that in mind once GOES S comes along.
And I haven't gone in there and taken another look at Parallax with the movement of GO16, so I'll definitely need to do that here as well.
Yeah, and as far as I know, GOES S launch still scheduled for March 1st, so not too much longer before GOES S comes along.
Yeah, that'll be nice. We're hoping we have it for the upcoming monsoon season.
Mm-hmm. Okay, any other questions for Stan? Okay, well, we want to thank Stan for leading the presentation for today and remind you that 2 weeks from today, January 24th, also at 18Z, will be our next GOES 16 webinar. It'll be led by Nelsie Ramos from NHC TAF B and talking about the Saharan air layer, some products that are available to analyze that. So thank you, everybody, and have a great day.